Got a couple questions on there, and then you can just let me know if you have any additional questions as we're going. Okay. And you'll
Okay.
be able to watch this on YouTube, on my YouTube channel, as soon as we're done, if you want to watch again later tonight.
Okay.
Yeah. Okay. So here with Dylan today, we're talking about functions for pre-calculus unit 1 test at one of the 204 schools. So this first question says, identify all the values that are in the domain. So domain means what you're allowed to plug in for X, right? So there's two things that are happening with this particular problem. You've got a square root in the top, and you have a variable in the denominator. So we actually have to consider both of these things because there's two no-nos. One no-no is you can't take the square root of a negative number, right?
Yes.
So one of the domain restrictions is that X has to be greater than or equal to 0. Because if it wasn't, you couldn't take the square root of it. So that's one of the restrictions. And the other restriction is that the denominator cannot equal 0. So I'm going to write x squared minus 4 cannot equal 0. So we have to solve this equation to find out what X can be. And maybe you can see right away, it can't be 2 and negative 2. Can you see that?
Yeah.
A couple ways to solve it. I'll factor it just because it's good practice. So when I factor that, I see, oh, X can't equal 2 and X can't equal negative 2. Now, one of these things we've already taken care of, right? We already know that X has to be greater than or equal 0. So do I even have to say this? Do I even have to say that X can't equal negative 2?
No.
No, because that's already taken care of with that first restriction, right?
Yeah.
So X, basically X has to be greater than 0 and X can't not equal positive 2. So now that we understand that, let's answer the question. Identify all values that are in the domain. Well, this is in the domain because it can be 0. This is not in the domain. Let me change colors here. This is in the domain. This is not in the domain. This is not in the domain. This is not in the domain because it's negative. So those two are in the domain. Okay. Now you could have also, since this was multiple choice, you could have just plugged them in to see, right?
Yeah.
You didn't have to go through all that, which I guess you could have done. I actually didn't look at it, that it was multiple choice. I was thinking they wanted me to put the domain, so I should have read it first. But now you see that's good practice for what I did. Actually, this is the one where I'm going to have to do this kind of thing. So what is the domain of this? Well, the no-nos, again, there's only really one no-no here. You can't have a negative. You can't have a negative in the denominator there. Or I'm sorry, you can't, sorry, that's not correct. There are two no-nos here. One is that you can't divide by 0. And the other one is you can't take the square root of a negative. So what that basically means is that X minus 1, that thing which is inside, right? That's the thing inside the square root, has to be not only greater than or equal to 0, it can't actually be equal to 0. It has to be greater than 0. Because if it was equal to 0, then you'd be dividing by 0. Does that make sense?
Yes.
So that means X has to be greater than positive 1. And how do I write that? I write that as this right here. Okay, so D is your answer. It goes from 1 to infinity, including 1. Oops, I'm so sorry. That's incorrect. Man, stupid. That's the correct answer because, like we said, it can't equal 1. So it's an open parentheses. That's the difference there.
Okay.
My bad. You knew that, right?
Yeah.
Yeah, good. All right, sorry about that. All right, which of the following are one-to-one functions? So one-to-one function means it passes the horizontal line test, meaning when I graph the function, I can't draw a horizontal line that goes through 2 points. That would not be one-to-one. So this function right here, are you good at identifying these functions real quickly?
No.
Do you know this is a parabola and it's shifted down 1.
Yeah. Mm-hmm.
So that's a parabola, and instead of starting at 0, 0, it starts there and it goes like that. And notice that does not pass the horizontal line test.
Mm-hmm.
If I drew a horizontal line anywhere above the vertex, I would get 2 points that have the same, there's 2 different x values that have the same y value, which means it's not 1 to 1. You understand that idea of 1 to 1?
Mm-hmm.
So this one right here is a cube root function, and a cube root function looks like, the basic cube root graph looks like this. That's your basic cube root function. Is that 1 to 1? Is a cube root function 1 to 1? Can I draw a horizontal line that will go through 2 points?
No.
I can't, so it is 1 to 1, right? So the only thing you have to ask is, did this change anything about it being 1 to 1? No, that just shifts it to the right 2, right? So it would start there, and this just flips it over the y-axis, so it would be something like this. Still 1 to 1.
Yeah.
Make sense?
Yes.
And for this one, I don't see what that said. What does it say? X is what? X is less than or equal to?
X is less than or equal to 1.
To 1. Okay. So this graph is a, remember what absolute value graphs look like?
Yes.
They look like what? What shape do they look like?
A V.
Good. They look like a V. And where does this move it? When you subtract 1 on the inside.
It moves it to the right 1.
Very good. So it's going to be right here. So I'll draw that. So it's going to be here, and it's going to start there and go up like a V and up like it's going to be a V. But it tells you that X is only less than or equal to 1. So this is my 1. So I have to erase this whole side. So is that 1 to 1?
Yeah.
It sure is. So it was important that they gave you that domain restrictions, because this is 1 to 1. Okay?
Yes.
All right, next. Which of the following are 1 to 1 functions?
I think that's the one we just did.
We did. Is that even, odd, or neither? All right, so even, odd, and neither. Let me just show you the, let me cut to the chase and show you the shortcut. If it's a polynomial function, odd functions for a polynomial are anything that has, they can have any odd degree, and they can't have any, that doesn't matter what the coefficients are, what the numbers in front are. So you can have an 8 in front, you can have a -5 in front, doesn't matter. As long as all of the exponents are odd, it's going to be an odd function.
Okay.
Okay?
Yes.
Are all the exponents odd here?
Yeah.
Not with this one, because this one is like x to the 0 power, and 0 is not an odd number. So that is not, this is actually neither.
Okay.
Okay. Now, if it was an even, so this is for odd. These are examples of odd functions. You could have 16x to the 7th plus minus 2x to the 5th plus 3x square cubed plus 5x. Or you could have 18, -18x to the 9th. That's odd. All of those are odd because all of these have only odd exponents on your variables.
Yeah.
But even functions are similar, but even functions can have a constant. You're allowed to have a constant like this for an even function. So even functions have to have even. So you can have 8x to the 4th plus 3x squared minus 2, that's even. Or you can have 16x to the 8th plus 3x squared, that's even.
Okay.
You understand what I'm saying? The existence of the constant function doesn't affect it, doesn't change it from being even. And the reason for that, I'll tell you the reasoning behind it, because they're asking you to justify your answer. An odd function satisfies this: f of -x equals negative f of x. You've probably seen that before.
Yeah.
So how would you justify it? Well, you would find out what f of negative x is, which is 1/2 times negative x cubed plus 1, which equals what happens to this negative when you cube it. What happens to a negative when you raise it to a power, when you multiply it by itself 3 times?
It stays. No, I don't know.
What's a negative x times a negative x times a negative x?
Oh, it's just x.
Nope, if there's 3 of them.
It's negative x.
So this stays negative. So now I have a negative 1/2 x cubed. You understand how I did that? But what happened to the 1? Did the sign change on the 1?
No.
No, so it's still plus 1.
Okay.
So does this thing equal negative f of x or not? Let's look at what negative f of x looks like. Negative f of x would be negative 1/2 x cubed plus 1. And what do I have to do with that negative sign?
You have to distribute it.
And what do I get when I distribute it?
Negative 1/2 x minus 1.
Right. Do you see how they're not the same? That's why it's neither.
Okay.
And it certainly isn't. Here's f of x. This isn't the same as this either, right? So that's why it's neither. Okay. Another way you could have justified it is you could have drawn it out and you could have said it's not symmetric about the origin or the x-axis.
Okay.
I'm sorry, or the y-axis.
Yeah.
Because even functions are symmetric. So an even function, f of negative x equals f of x, and it's symmetric to the y-axis. This odd functions are symmetric to the origin, which means you flip it both over the y and then over the x, and you get back to the same thing. That's what the symmetric to the origin means.
Okay.
Okay.
Yes.
Did you learn that in class?
Yeah.
I hope. Okay, good.
Yeah.
So that's how you do it. Now, what is the domain of this? Well, domain, again, what I do is I say, what can this not be? This is a little bit of a trickier one. What has to be true about this? X squared plus 3x plus 2 has to be what?
I don't know.
Well, what would cause a problem? What would be problematic for a square root? What are you not allowed to do?
Put negative.
Right. So that whole thing, this whole thing has to be what?
Positive.
It has to be greater than or equal to 0, right?
Yes.
But now, why can I ignore this equal to part?
Because 0 is not negative, so it can be 0.
Well, it could be 0, but that wouldn't cause a problem with the square root. But what would that cause a problem? If this was 0, what would be the problem? If this thing equaled 0, what would this be? It would be 1 over, what's the square root of 0?
0.
And are you allowed to do that? Are you allowed to divide by 0?
No.
That would be the problem. So that's why we can erase the equal to sign for this.
Okay.
You understand what I'm saying?
Yes.
So now we have to solve this inequality. X squared plus 3x plus 2 has to be greater than or equal to 0. Okay. Now I'm going to show you the way I prefer to do this. I prefer to do this by graphing it and looking at where that graph is greater than 0. Do you remember how to graph quadratics?
Yeah.
So to graph a quadratic, you can either put it in vertex form, but I'm not going to mess with that. I'm going to actually factor I'm going to factor this into x plus 2 and x plus 1. And I'm looking at this equation and I'm thinking, oh, my two zeros are, remember this, x equals -2 and x equals -1.
Yeah.
See what I did there?
Mhm.
So -2 and -1 are my zeros. And it's going to open because it says greater than. I'm sorry, not because the leading coefficient is 1, it's opening up. So my graph is going to look like this. Something like that. Now, what was I trying to do? I was trying to find out what the domain of this was. In other words, I have to answer this question: when does this thing greater than 0? Look at this graph over here and tell me when the y value is bigger than 0 on this graph. When is the y value bigger than 0?
Where's the graph?
Can you not see it on my Jamboard?
No.
I'm looking at it. You're not on page 2 of 2?
I am.
What do you see on yours? You might have to close it down and open it back up. I'm not sure why you can't see it on Zoom, right?
Yes. Let me double check.
I believe I'm sharing it with you.
Yeah. I'll double check really fast. Okay, I see it now. It's just not loading on Zoom.
Oh, that's weird. You're looking at it on
Now I'm just on Jamboard.
Jamboard, but you can't see it on Zoom. Here, Micah's just joining us. Let's see if he sees it. Hey, Micah, do you see on Zoom, do you see the graph that I drew on the bottom, the parabola that I drew on the bottom?
The quadratic on the
yeah.
graph. Yeah, I can see.
Yep. And you can see the parabola that I drew next to it. The picture of the graph.
Oh yeah.
Okay. Yeah, I think Dylan, I don't know why you can't see it on your Zoom, but I think maybe something with your Zoom. I don't know.
Yeah, I'm not sure.
It's on mine. Well, you can see it on the Jamboard, right?
Yeah, I can see it anyway, so it's fine.
Okay. So can you see that picture, and do you see where it's greater than 0? Where would that be greater than 0? Can you see that it's greater than 0 to the left of -2 and to the right of -1?
Yeah.
Can you see that? That's where it's greater than 0. Now, the way some teachers teach it is they tell you to do like a sign analysis. They tell you just to put like a single, just the x-axis, and put in your -2 and put in your zeros, and then analyze what the sign is going to be to the left, in the middle, and to the right. So like plug in a value and put the value in there, and that's fine, that works. But to me, it's not that much harder. In fact, it's not harder, in my opinion, just to graph it.
Yeah.
So you can see that that's going to be positive, that's going to be negative, and that's going to be positive to the right. To the left of the -2 is positive. In between -2 and -1 is going to be negative, and to the right it's going to be positive. So the domain of this is kind of a tricky problem, but the domain of this is that x can be from -infinity to -2. It can't be -2, because if it was, I would be dividing 1 by 0, like right here, right?
Yes.
Or, so I put union, or it can be from -1 to infinity.
Okay.
Does that make sense how I did that?
Yes.
All right. I'm gonna let you keep asking some questions, because I bet you still have a few, huh?
Yeah.
Micah, is this the stuff you're working on right now too?
I believe that was on my last test.
Okay. Well, so it's not going to hurt you to listen in to Dylan's questions. You can stick around, and then I think Dylan's got to go pretty soon because she's got work or something, or a athletic competition, right?
Yeah, I have dance.
Okay. So do you have another question, Dylan, that you can find that we can do together?
Do you want me to put one on the Jamboard?
Yeah, or you can just say it to me and I'll write it down if that's easier.
Yeah, well, there's a graph, so I think I'll just.
Okay. Yeah, go ahead and do that then.
Okay.
Mike, do you have your questions posted on your Jamboard?
Yeah, they're on my Jamboard. I made a new one. Should I just put the link for it in the chat?
You know what? Just share it with me and I'll be able to open it. Did you share it with me? napervilletutor@gmail.com.
Give me 1 second. I can do that.
Yeah, go ahead.
Okay.
All right, so this is a piecewise function. They want us to write the equation of the piecewise function. So I'm going to make this bigger so we can see it better. So to do this, we have to, first of all, what I like to do is start with the domain pieces. So you can see, I think of it like this. I'm scanning, right? I'm thinking domain. Okay, so from negative infinity all the way to -1, not including it because of the open sign.
Yes.
My graph is going to be this line right here, right?
Mm-hmm.
So I'm going to write from when x is less than -1. So that's the domain restriction for this. When x is less than -1, see how it's -1 here and it's less than that?
Mm-hmm.
Your graph is defined by this line. So I have to now come up with the equation of the line. And in order to do that, sometimes it's easier to kind of think about what that line would have looked like if it went straight. Do you see what it would have been?
Yeah.
What would the y-intercept have been?
0.
Mm-hmm. And what's the slope?
Negative, or yeah, -1.
Not -1 because it's going up from left to right.
Sorry, 1.
+1. So my equation is just x, y equals x, because it's 1x plus 0, right?
Yes.
So y equals x. Got it?
Mm-hmm.
Now from -1 to 2, you see how I'm looking where that's going? From -1 to 2, you follow what how I'm looking at that?
Yes.
From -1 to 2, so I'm going to write from -1 to 2, and so when x is between -1 and 2, and see how both dots are filled in?
Yeah.
So I put the equal to underneath those. Got it?
Mm-hmm.
It's a parabola. And the parabola is shifted up 1, right? Normally the parabola is here, but now it's shifted up 1. And let's see if it's anything else is different. Let's see, when I go over 1, I go up 1. So that's normal, right? Because a quadratic means you square it. When I go over 1, I go up 1 squared. When I go over 2 from the vertex, I go up 2 squared. Oh yeah, 4, perfect. So I didn't get stretched at all.
Mm-hmm.
So my equation is just x squared, but it's shifted up 1. So what do I do to make it shifted up 1?
+1.
Good, on the outside, right?
Yeah.
Perfect, there's that one. And the last piece goes from x, it's greater than 2, right? Do you see why I'm doing that?
Yes.
Because it's an open circle, so I don't put the equal to sign. It's greater than 2. So when x is greater than 2, what is the equation of a horizontal line?
Or x equals 2.
In this case, it's
sorry, -1.
Exactly. X equals -1. Very good. So there's my piecewise function.
Okay.
That make sense?
Yes.
You have another one to do real quick? We can probably do, if you have another piecewise function, that was kind of an easy one.
Yeah.
Or it doesn't have to be that. It can be another thing. You got
Yeah,
just a couple minutes left before you pray. Okay. So this problem says they want, okay, we're doing inverses now. So they want us to graph the inverses on the same coordinate plane. So to find the inverse, we're going to first, well, let's first graph this one. I'll do this in yellow. So this graph would be it's going to be the absolute value function. I'm sorry, the square root function, which normally goes like this, but it's shifted down 2 and it's flipped over the y-axis. So it first gets flipped here and then it gets shifted down 2. So the graph's going to be here, and you go up 1 over 1. You go over 1, 2, 3, 4, up 2 and over 4 like that. So that's what your graph is going to look like. It's going to be half of a parabola opening up to the left. Okay. And what I always like to do is I know I did that kind of fast.
Yeah.
What I like to do is then just try kind of put these test points in here. When I plug -1 in, that's not right. I can't plug in -1. I didn't do that right. Did I flip it over the wrong thing?
I think it's flipped over the x-axis.
Yeah, that's not right. That doesn't flip that way. Yes, it's flipped over the x-axis. Duh. Yeah, the negative flips it over the x-axis, and then it's shifted down too. So it's here, and it's here, and it's here. That's the right answer. That's why I always check points, because sometimes in my haste I make mistakes. Okay, and if I plug in this point 1, you'll see that it's -1 minus 2, which is -3. That checks out. If I plug in 4, that's square root of 4 is 2. -2 minus 2 is -4. That checks out. So that's right. Now, the inverse equation, the way you find the inverse is you interchange these two variables. So you call that x and you call this y, and then you solve for your y.
Okay.
So to solve for y, I'm going to add 2 to both sides. Now I'm going to get rid of the negative by multiplying both sides by negative. So -x minus 2 equals the square root of y. And now I square both sides to get rid of the square root. So y equals -x minus 2 squared. Now, the only problem is when you do that, that's going to look like a parabola, right? That's a parabola. So that would look like this, but you need to consider the fact that you had a limited domain. Your limited your domain for this original function was limited to, I'm going to write it up here so you can see. Your domain was x had to be greater than or equal to 0. So when you flip the x and the y, you have to write that y has to be greater than or equal to 0.
Okay.
You have to impose that domain restriction, or that, not the domain, you have to impose that restriction on it. Did I say that right? Does y have to be greater, or does x have to be? No, I think it is x actually. Well, let's graph this and we'll see. What kind of graph would this be if I've got a negative x minus 2? I'm going to erase this for a second so I can write underneath it. This is going to be like -1 times x plus 2 squared. So I can actually square both of these, so that's going to be a positive. It's basically the same as x plus 2 squared, which would be shifted left 2. So your graph would be shifted left 2, and it would go, your parabola would look like this normally.
Yeah.
But you can't put both of them in there. So let's see. I know what the answer is going to be. It's going to be, I have to erase this side of it.
Mhm.
But I'm trying to think of how I explain that to you, or how I justify that to you. What'd your teacher say about that? If I draw in this line, y equals x right here,
Yeah.
I know that this has to be a reflection. Inverses have to be reflected over the line y equals x.
Mhm.
That's how I know it's going to be that. But they want it, let's see, they said, let me read the directions. It says graph both of them on the same coordinate plane. So I guess what we could have done, no, then it said find the equation of the inverse. So we did have to find the equation. So the way you graph it before finding the equation is you take these points right here. This point is 0, -2, and you flip the x and the y. So this point is -2, 0,
Mhm.
right?
Yes.
You understand that? This point is 1, -3. So this point is going to be -3, 1.
Mhm. Okay.
That's how you know how to do it. So I guess maybe just do that first, and then put your domain restriction in there.
Okay.
Your
Yeah.
domain, so you can see that your domain restriction is going to have to be that x is less than or equal to -2.
Mhm.
That's what your restriction is going to be.
Yeah.
That makes sense?
Yes.
So f inverse of x is this right here, what I just wrote, but along with this domain restriction. The domain for f of x is going to be, the domain is this right here.
Yeah.
The domain is that x has to be greater than or equal to 0. And the domain for the inverse right here, right? Think about it's from 0 to -3. So I guess let's do this in interval notation. It's from 0 to infinity is your domain, and the domain for the inverse function goes from -infinity to -2. -infinity to -2 inclusive.
Mhm.
Good?
Yes.
All right. That is, the video is going to be on YouTube. If you go to my YouTube channel, you might have to subscribe, and then you can see my live stuff.
Okay.
If you can't find it, text me